Here we're asked to consider the parent function f of x equals x squared. When I immediately see that, I think quadratic. I think U-shaped parabola-like thing. First step is to graph it. So if you're not sure how to graph x and y table, plug in some values. The first one's nice and easy, right? Because I'm doing 0, 0. 1, 1, because 1 squared is 1. Negative 1, positive 1, because negative 1 squared is positive 1. 2, 4, negative 2, 4, 3, 9, negative 3, 9. Again, I'm not taking a lot of time to actually plug in these numbers because quadratics you should be fairly used to graphing, but when we're doing this, just make sure that you are getting the right points, and if you're not sure how to graph it, plug in x values and find y values. Sometimes we'll get a little bit harder than that, but for now, let's just always focus on that if we can't do it. So now it says write an equation for f 1/2 of x, and then sketch that and describe the transformation. So really what I want to do here first is I'm going to take this and I'm going to plug in 1/2 x for wherever I see x. So I got y equals 1/2 x squared, which I'm going to distribute that squared here. I'm going to go y equals 1/4 x squared. You could technically graph it like this if you wanted to. I prefer distributing, but up to you. Basically, because I'm going to do the same thing, right? I'm going to still do an x and a y table here and see what happens. So if I plug in 1 squared is 1 times 1/4 is 1/4. If I plug in 0, it's still 0. If I plug in negative 1 squared is 1, I get 1/4. So we're still going to get this symmetrical over the y-axis here, we can see. But now let's get some bigger numbers in here. So 2 squared is 4. 4 times 1/4 is 1. I'm going to do it on the other side too because I don't want to keep doing that. So 3 squared is 9. 9 times 1/4 is 2 1/4. Nope. Yep, 2 1/4. Then let's go with 4. And then 4 squared is 16. 16 times 1/4 is 4. And that kind of gives me enough detail here to see what's happening. So if I'm going to describe this transformation, ooh, that got wiggly. Describe this transformation, I would say one of two things. Either it is a vertical compression because it's getting like squished down from the top, or you could say that it is a horizontal stretch, because if you were to take the sides and pull left and right, that's what it kind of looks like is happening, which kind of describes things that we know about the B value of transformations and the A value. So that's kind of what we got about transformations.